good segue into that question. So how did you get interested? Because in 2006 you have done
yes,
engineering physics, right?
Yeah, engineering physics in IIT Madras when we were the first batch of engineering physics.
Wow.
And this was a branch which was there only in IIT Bombay prior to that, and it was a very niche branch. So it tries to bridge the gap between engineering, which is very applied and doesn't often ask questions about what lay beneath, and then tries to approach it from that, tries to bridge fundamental science with engineering, and also from a purely opportunities point of view, it gives a student a very well-rounded understanding of both fields.
Right.
But so my undergraduate training was in engineering physics, and when I was doing that, I was drawn more to physics.
Okay.
And it's only later that I understood how much the engineering part actually helped me in my own work. And then I went to Maryland to pursue a PhD.
Okay.
And Maryland is a very big university.
It has just 1 second. I want to have one more question on the undergrad side.
Yes.
So you chose, it was a clear choice. You said, okay, I want this. I'm going to go for this. Yeah.
Yes.
Why?
I have always liked physics since I was very young.
Okay.
I have been interested in physics and mathematics.
Okay.
They were my primary subjects.
So engineering physics.
Engineering physics, yes. And also, of course, Madras being very close to where I was from.
Okay.
So it was easy choice.
So very nice. So you were very clear you're going to get into that. You got that.
Yes.
And then while you were pursuing
No, I was not very clear I would get into that.
Okay.
I wanted it and I got it, yes.
Perfect. So then while you're studying, your inclination kind of goes into physics part more.
Yes.
In your undergrad, right?
Yes.
Then you apply for your PhD.
Yes.
So that time also you were clear, okay, this is like, how did that clarity come in? Because undergrad in physics...
Actually, yeah. So did I do my PhD starting from day one in quantum computation? Actually, no.
No.
So I initially went to Maryland to work in nonlinear dynamics, which is purely classical. But of course, you have quantum mechanical versions of nonlinear dynamics also.
Okay.
Chaos, as chaos theory as it is popularly known. So I was more interested in that during my undergrad, primarily because my mentors and professors in IIT Madras were working in that field, and I interacted more with them. But then once I went to Maryland, and after 1 year of coursework, I took my first quantum field theory course, which is essentially one step beyond quantum mechanics.
Oh, okay.
Okay, so this is how the actual theory of light matter interaction works.
Okay.
And this ties into what is done in the Large Hadron Collider in CERN. This is particle physics.
Okay.
What we are talking about is subnuclear particles and subatomic particles. So I was interested in that. So I started working as a high energy physicist.
Okay.
For a couple years, I was
by subatomic, the quarks and stuff.
Exactly, exactly, but not
not to that level.
No, it's exactly that level, but I was working on different problems. Yes. So my problems were mostly related to what we call supersymmetry and things like that. So I was working on those, and after a few years.
What was the research, broader research, PhD?
My PhD problem at that point was on supersymmetry.
Okay.
So,
can you explain supersymmetry?
Well, it's. I think that will go into a tangent. It is not the focus of.
Give us the abstract.
Well, so we have what is called the standard model of particle physics. So we have 4 fundamental forces.
Okay.
The electromagnetic, gravitational, the weak, and the strong forces.
Nuclear.
Yeah, the nuclear forces. The 2 nuclear forces, electromagnetic and gravitational. Now, this standard model of particle physics essentially tries to tie everything together into one structure.
Okay.
One theory.
Okay.
One theory to explain everything. It's like that one ring to bind them all in Lord of the Rings.
Yeah.
So it's like the one theory to explain everything. The Holy Grail is, of course, the theory of everything,
Right.
which people,
String theory is one.
String theory is one candidate for such. So this is called the standard model of particle physics. It's very well accepted, but there are certain theoretical extensions that people started looking at, and those extensions proposed newer particles and newer symmetries, and supersymmetry is one such. Okay, and it kind of goes closer to string theory. It's on the way. If you want to say from particle physics as we know today to string theory, supersymmetry is somewhere on the way. Yeah.
So that was your PhD?
That was my initial PhD, problem. But later I got more interested in quantum. From very high energy, I was more interested in the very low energy.
What is that?
Which is artificial atoms and microwaves. So I went into the experimental aspects of that. And I took a course in experimental graduate laboratory course. Actually, that course played a huge role in me liking experiments. And after that, I moved.
So that's where your engineering skills also helped. You were able to design
absolutely.
your own. Okay, cool.
Yeah.